You're probably familiar with these multiplication tables. Think of doing detentions or tables as paying interest on a late payment that you made. The bank is just taking more of your money, but in this case, the interest you're paying is time. So don't be late to class and don't waste any more time on doing detentions.
Hey guys, let's go over this project support packet, Introduction 0, Standards and Learning Targets, our standard for mathematical content. Write a function defined by expression in different but equivalent forms to reveal and explain different properties of the function. Also, use the process of factoring and completing the square in a quadratic function to show zero, extreme values, and symmetry of the graph and interpret these in context. Our learning goal is in this lesson, students will learn how to convert quadratic functions between the three forms to support their math knowledge for their performance task assessment. The three quadratic forms are standard form, y equals ax squared plus bx plus c, factored form, y equals a times x minus p, x minus q, sometimes they call that r1, r2, and vertex form, y equals a times x minus h squared plus k. Introduction number 1, you're going to create a foldable, so let's summarize the three quadratic forms with the foldable. Attach it to the back of this packet. In class, we either walked around or passed the clipboards around, and if you're absent, I'm about to show you this video. And you can also click here for the information. You're going to take a piece of paper and do like you did before. You're just going to fold it to the three circles you see there. And make sure not to fold it over those circles. So, see it. So I'm only folding it to the circles. So I can still see the circles. Does that make sense? My finger is still there, right? And you can turn it sideways. So again, you're not folding it completely over it. Don't do that. You can still see the holes. Let's go ahead and write forms of quadratics. Forms of quadratics. And then what was one of the forms that we just learned? So let's write standard form, but how many forms do we have? So I'm going to turn this, and then I'm just going to divide those in thirds. So maybe between the two dots, just draw a line. So first one, standard form. Class of standard form, how many parentheses? What is standard form? Alright, what's another form you learned about? Factor. Let's write that. Factored form. Okay, question. Does factor form have any parentheses? How many? Okay. Leave some space. We're going to actually write the equation out. So the formula is, put y equals in front of this one too. These are your equations. A parentheses x minus p, x minus q. So factored form has two sets of parentheses. The hard part about factored form is that the formula has to have this minus. And the last one is vertex form. Let's write it. How many parentheses does vertex form have? Y equals a times x minus h squared plus k. So those are our three forms. On the inside, I'm going to need 4 columns. So this line that's dotted is the one you just was the folded line. Here. You guys will get your quizzes back tomorrow. Some of you guys need to work on your penmanship. Penmanship is neatness. Why does neatness count? If I cannot read what you're writing, then your communication's wrong. Axis of symmetry. Vertex. Miscellaneous or random stuff. What does that stand for? It's like random stuff, right? Like, you know, on your desk at home, like you have a bunch of junk, you just kind of shove it into a box. And then this one's graph. And then based on those 3 lines from the front that you drew, I'm going to go ahead and draw it across. So again, these lines that I'm drawing are from the lines from the front. So eventually then, just like we did before, you can just open this up, cut it, you have these open tabs. Go ahead and draw some graphs. There's some good news and bad news about your foldable. What do you guys want to hear first? The bad news is on a quiz or a test, you can only have 1 page of formulas. How many pages? Can't take your whole notebook. And now time for the good news is, if you wanted to use this on your next quiz or test, you could, because this is like one page. But you can't use the other pages that you've created. Or you're the better student, you can just take this information and just transfer it to your formula sheet. Put an example, and then we'll make it obsolete, right? Okay, what is the equation for the axis of symmetry for the standard form? Maybe you didn't know this. This is the front part of the quadratic formula. X equals negative b over 2a. The vertex is an ordered pair, so I want you to write xy. And to get the x value, you're going to make an equation negative b over 2a, which we just got from this one. And then you actually put that into your function, and you get an output. So this is function notation. I want to show you guys a little, I don't know, I call it a trick. Vertex ends with x. It helps you find the x value. X equals negative b over 2a. Alright, so we're on standard form. We just finished the axis of symmetry, the vertex. Now let's go to miscellaneous. Standard form is ax squared plus bx plus c. So the big idea for the standard form is this c. Let's underline that. Because your y-intercept is 0, comma, c. What does that mean? When you make your x value 0, you get to find a y value, and this y value is your y-intercept. So now I'm going to take a different color pen. I'm going to draw a parabola here. And let's just say my parabola looks something like this. Everyone say curved. Should not be a V, that would be bad. Well, that y-intercept is where it crosses the y-axis. This is the y-axis right here, and this is your y-intercept. So that is the advantage of standard form. Now, one thing we need to draw is also at your lowest point of your skateboard ramp is something called the vertex. Everyone say vertex. The dotted line is called the axis of symmetry. Axis of symmetry. This is my vertex. And the yellow one there is the y-intercept. It's where it crosses the y-axis. So that is the standard form. Alright, so let's go ahead and finish up here. We just finished the standard form. Press pause and record that if you need to. Let's go ahead and move on to the factored form. And in the factored form, Your axis of symmetry is going to be x equals the h value. And you put a little star here. The h is the opposite sign in the equation. What does that mean? If you flip back, whoops, that was the wrong one. This is supposed to be down. H is the opposite. It's supposed to be down there. Sign in the equation. So the common mistake here is to think that the hard part in this formula is that this always has to have a minus sign. So the h value is just like this. Let's finish vertex form. Vertex form has the vertex h, comma, k. And I'm going to put x and y above it. It's just an order pair. Again, be careful about the h value. The h is opposite sign in the equation. Miscellaneous? Nothing. Let's go ahead and draw a graph, which we did here. And if you just draw some kind of dotted line, this dotted line here, just like the other one, is the AOS, the axis of symmetry. This is for your parabola folding. Let's put one on there. And then from here it's left 2, down 4, right 2, 4. And we're going to graph one with something like this. And right here we have the vertex. And that is the order pair HK. And again, I want to show you a visual of what the axis of symmetry is like. Here I have a mirror. Let's see if we can get it on there. And there it is. It is reflecting what the other side is like, right? Okay. Last one is the factored form. How do you know it's factored form? It has 2 sets of parentheses. So let's go right there. And the axis of symmetry is, let's see if we can kind of fix that. It is P plus Q. So let's make this a P. Use your art skills, just make it thicker. There we go. Plus Q divided by 2. P plus Q divided by 2. And just change that to say P and Q are the opposite sign in the equation. So again, this is hard for students, is that the P and Q value, if I cover it up, there's a minus sign in the formula. So it is your P and your Q. When it says opposite of that, normally you guys think of the negative sign. So if you have like -3, then your P value is actually just P value is just 3. So the axis of symmetry is x equals P plus Q divided by 2. P and Q are the opposite signs in the equations. let's go over here. How do you find the vertex? The vertex is going to be the x value. Let's put an x, comma y. The x value is going to be p plus q divided by. And then whatever you get for this x value, if you put into this function notation, basically just means plug it into the equation again. You'll get a y value. Your output is your answer, and that will be an order pair x, comma y. Now, what is the point of finding the factored form? Factored form helps us find the x-intercept. Where it crosses the x-axis. And those order pairs are going to be p, comma, 0, and q, 0. So if I go over here and just graph a simple graph, let's just do a quick one. So say we do the axis of symmetry here. ULS. And let's just say we have this goes 1, 1, 1, 2, 4, 2, 4. Let's just say this is my graph here. And notice this is my vertex, but the big idea is that the x-intercept of the p and the q's are right there. So this is the vertex. Again, the big idea is the highlighted colors I'm showing. Is that the factor form helps you find the x-intercept, the standard form helps you find the y-intercept, the vertex form, let's highlight this one, we didn't. The HK helps us find the vertex fastest. And something we didn't really point out, remember, we already know about concavity, is that they all have an A value. And that tells you whether the graph opens up if it's positive, or negative if it's negative. That's a negative if it's opening down. And that's your foldable. Okay, introduction number 2. Let's see if you recognize the different forms now with your foldable. Consider quadratic functions, a, b, and c. You're going to write some letters in here, and then some numbers. Letters, then numbers. And I'll show you the answers in about 5 seconds. Go ahead and press pause and try those. Here are your answers. B. This one's factor form because it has 2 sets of parentheses. 1, 2. This choice, C, is the vertex form. Why? Because there is 1 set of parentheses, it's to the power of 2, and then you have a constant on the outside. A is standard form. Why? Because it has 0 sets of parentheses. Introduction number 3, let's see if you recognize the different forms in a little bit more difficult way. Determine which form of the quadratic function would be most efficient to write the function using the given information. Draw a picture for each one using the given information. Write S for standard form, F for factor form, V for vertex form, and none in the answer box. So, another answer over here. Only in A here, there's 2 answers, so you can write something there. B, 1 answer, so draw a picture based on this, look at your foldable, and then go ahead and pick one of your letters there. And then I'll show you guys the answers in a little bit. Tina, what keyword gives it away on part A? Minimum. Which one? She says y-intercept. Thumbs up, thumbs down. Well, if I look at my foldable, you're kind of going reverse, right? You're kind of figuring out, based on all this information here, which of my factor form it is, right? Well, I see the word intercept highlighted in mine, So I've seen several people not have highlighted it. The reason why we highlight it because that's the most important information on standard form, which is the y-intercept. Now if you graphed it, you might have something like this, 0, 15, right 6 down, negative 75, and your graph might look something like this. And then the most important thing you have on that graph is the y-intercept. Which is which form? Standard form. Raise your hand if you got that. Okay. Alright. Now if you graph the next one, Cecilia, what did you guess, or what did you say as your answer was for B? Factored form. How did you get that? Don't tell me you guessed. Okay, now these are not equations. This is just kind of like hints, so that does not correlate to the formula, if that makes sense. So the parentheses only works when you're looking at a formula. Here we don't have formulas, we just have ordered pairs. Anything else, Cecilia? If you graph this, Cecilia, how do you graph 2, 0? From the origin. Left, right, up, down, stay. How do you get there? So you need to go 2 on the x values. Positive 2. So is that left or right? Cecilia? So right, 2, stay. How would you graph 8, 0? So 8 on the x values, so x's are left and right, so you're going to go right, 8, and stay. So these 2 points are called the x-intercepts because they cross the x-axis. And it has 4, 6, probably not as important, but tells us the graph opens down. Not important. What's important is that we know that it crosses the x-axis. Those are called factored form. Raise your hand if you got that. And let's do the last one. Sebastian. Vertex form. How did you get vertex? Okay, each of them have an x and y. Anything else? Alright, so if I just graph the order pairs, right 100, up 75. That's this one. 450, so right 450, doesn't matter what it is, but it's the same value, the same y value, so they have the same height, and then in between them, just a little bit past the first one, you're going to go up a little bit higher. Now I can probably sketch a graph that looks something like this. Do I know where it crosses the x-axis, class? No, so it's not factored form. Do I know where it crosses the y-axis? No, you can create a formula, but we don't have that. Does it tell us the vertex? Well, the vertex would have been the midpoint between 100 and 150, so that would be 550 divided by 2, which is 275. Does it give us 275 and then something? No. So I would say the answer is none. None. Alright, so we're supposed to figure out which form they are based on the clues they've given us. Determine which form of the quadratic function would be most efficient to write the function using given information. So in the blanks it says write standard, factored, or none on these forms. Let's do D together. I have 3 order pairs, so these are not formulas or equations. Some students were telling me, Mr. Ng, it has 3 order pairs, or 3 parentheses, and we don't have one that has 3 parentheses. Well, the reason why it's none of these is because it's not the word none. It's because these are order pairs. They're not formulas. So now if I actually graph these order pairs, right 3, up 3, right 4, up 3, wait, right 4, up 3, and then right 5, up 3. I have 3 dots in a line. Class, is that quadratic? No, so the answer is none. It's a line. It's a horizontal line. It's a horizontal line with no slope. E. Oh, this is good. X-intercept. X-intercept. On your foldable, point to the one that has X-intercepts. Show your partner. On the count of 3, we're going to say the form. Ready? 1, 2, 3. Factored form. That's the big idea for factored form. So if you don't have that on your foldable, highlight the word X-intercept. Okay? Now, if you didn't understand that, you can always graph the order pairs. 7.90, so that's to the right. 7.9 and stay. Negative 7.90 and stay. And then you have this other pair, negative 4, 4. So it might look something like this. And that third order pair there is just to help you understand that it's graphed up, not super important to us. Whoops, I graphed it on the wrong graph. But the big idea is that these are x-intercepts, and that tells us this is the factored form. Factored form. Alright, we got D, we got E, let's do F. Sorry, I used the wrong graph, let's do it on this one. Roots, not sure what a root is, but it gives me an order pair, so let's graph it, 3, 0. And then another root at 12, 0. Oh, look, they're crossing this line. What is this line called, class? X, and someone just said x-intercepts, and a point 10, 2. Okay, I don't really care what the graph looks like. The big idea is that you see the word roots. Roots are another word for x-intercepts. You can write that on your sheet. So let's write that. Roots. Roots and x-intercepts are the same, so you're going to use factored form. So just as like superly summarize it, right? Like less words as possible. Mr. Ng, you're saying when you have dots here on this line, then it's factored form? The answer is yes. Okay. Alright, last problem. Max hits a baseball off a tee that is 3 feet high. Oh, word problem. So there's the tee, 3 feet high. And the tee ball is probably going to look something like this, right? It's quadratic. The ball reaches a maximum height of 20. So it's saying this is 20. 20. When it is 15 feet away from the tee. So here it is 15 feet. Okay, so if it's 15 feet away from the tee, let's see if I can super zoom in my best I can. Give it a second to focus. This is 3. That's the height of the tee ball at 20 feet, and this is 15 feet away. So if it's 15 feet away, that's the x. And if it's 20 feet high, that is the highest point. That's my y value. So I have 1520 of a parabola. It's the maximum height. Another word for maximum is vertex. HK. What form is that, class? Vertex form. Okay, so 4 examples, using the clues, trying to use my foldable, and then I can figure out the rest of this.
Hey guys, we've been working with the 3 forms of quadratic. We started with standard form at 1.1, 1.2, and you'll notice it has no parentheses, y equals ax squared plus bx plus c. The next form we went to was factoring them. So how do you go from no parentheses to two sets of them? Well, if you see this blue line here, we need to factor. Take out the greatest common factor, then we do our x box. So this is factored form, has two sets of parentheses. Now let's just say you want to go back to standard form. Well, you want to get rid of those parentheses. You have multiplication there, so you can just simplify using PEMDAS and basically just put it on the outside of your boxes, get stuff in the inside of the box, and add. Then, that was 1.4, and then 1.5, we learned about vertex form. Well, how do you get to vertex form? You're going to have to do CTS, complete and square. So you take your B value, half of it, and square it. This is your C value. Now, if you're on the same side of the equation, that C value should be the opposite, right? One positive, one negative. But if it's across the equal sign, then they'll be the same because A equals 0. Vertex form is y equals a times x minus h squared plus k. And this is saying you want to go back to standard form. Okay, you want to, you can't distribute the power of 2. You have 2 of these, so quantity 2, count 2. So you have 2 parentheses, multiply those with the box, multiply it by a, and then when you're done, you add k because of PEMDAS. I want you to notice you cannot go from green to pink. You can, it's an advanced form. I forgot, Vietta's or something like Vietta's method or something like that. But anyways, you always want to go back to standard form. You kind of need that from your project. So this purple dotted line here cuts this parabola in half. And so this is called the axis of symmetry, the AOS. And there's 3 ways of finding it. For the green, you just take your P and your Q values and divide it by 2. Standard form, x equals negative b over 2a. Or in vertex form, you just take your h value, and that's your axis of symmetry. You'll also notice these dots in colors here. So standard form, the c value is your y-intercept. Factor form, the p and the q are these green ones. Those help us find the zeros, the x-intercept, the roots. And then over here, the vertex form, hk, helps us find the max or minimum. In this case, it is the minimum.
Are you late to class all the time? Are red lights stopping you from turning in your late work and you simply don't have any restroom passes to spare? Well, we've got you covered with Savannah's Insurance so that you can get good grades without having to worry about detention ever again. So what are you waiting for? Get a quote today and save up to 20% off multiplication charts.